Welcome back, everyone. Sorry it's been a few weeks since the last episode. I've decided to slow down a little bit. I was doing a little bit too much all at one time, so I was trying to figure out the hardware side and also trying to program at the same time. Kind of jumping forwards, skipping those steps where I said, hey, I want to take this one step at a time. Well, I skipped that, and it kind of threw me off, and I think I was being a little bit inefficient. So I'm going to concentrate on the hardware side and figure out all of that before going on to, I guess, the more advanced features of what we're trying to achieve. Last episode, we worked on this. We examined this, reverse engineered it, found some design flaws that we can improve upon, and that's what we're going to do this week. So what I went and did was start building a prototype on my breadboard here. I wish I could use all the same parts as what was being used in Mustang's design, but there's a lot of parts in here that aren't available in the breadboard design. So what I needed to do, to recap last time, what I need to do is to figure out a way to drive the relays without using the direct GPIO ports. I think we're running too much current through the GPIO ports with his design. So what I did some research to figure out how to transistors and specifically MOSFETs to drive the relays as its own switch. I came with the design decision to use MOSFETs since it is a voltage driven device versus the BJT transistor, which is a current switching device. I found a design that's very similar, kind of it's what they use for the relay devices. So as you can see with the relay devices, they're using more parts in here to drive the relay, and they're doing what we want to do. We're using the MOSFET to control the device. I wanted to talk more about the relay modules and what we're going to do because it's such a critical component of our system. So I found this diagram on the internet. Aftermarket relay modules that you buy uses an optocoupler, which is a LED sensor. It sends a light to turn on and off this section here. It's basically there for protection of your microcontroller and creating an isolating circuit. From my research, we don't need this. It's an added protection that we're not going to need. The big thing is looking at this here. I believe they're either using a transistor or MOSFET to complete the circuit to allow relay coil to activate and deactivate. We'll get into this more as we design it, but I do have plans on how to fix the issue that we have, and we'll just have to redesign the PCB and add some additional components. Other things I did in the prototype here is I have my speed control here as well. So we're using the same digipod as we did earlier, so I'm not going to go into that. It's the Renaissance X, one of the previous episodes. So what I'm going to do next is bring this out to the garage, do some testing. Back in the garage, going to test out our prototype here. Do what we've done every other time. Here we go. So you see I have to use this separate power supply so I don't overload the ESP32. Of course, we're going to build this into our final design with the buck converter and using a 12-volt rail from the motor. So power's on. I heard it click. All right, let's go ahead and just show steering off real quick, just so we know that's working. Yep, right works, left works. Motor's on. Let's just tap the remote to see. There it goes. Yep. So I can put that in software code to fix that to start at a closer to 0. Again, it's because of the higher ohms that we're using on this thing. Okay, so we got everything working perfect. So I can kind of mess around with it and make some changes and fix some things. It's good to know that's actually working though. There you have it, back in from the garage. We have a working prototype. We solved the problem with using the GPIO directly to drive the relays. We're using MOSFETs as an on and off switch for the relay. Instead of using the 40 to 50 milliamps, that would be over the capacity of the ESP32 board. So now that we have a working prototype, I am going to work on turning this into something similar to this. This is a good starting point. It will help me design it almost exactly, at least the size-wise, and be able to stack it on top of the other modules. The next step for me is learning what software I need to use to create this PCB, and then learning what components I'm going to be able to use as well. A lot of the components I'm going to use are the same as Mustang's here. I will have to look at how to design the buck converter onto the PCB. I thought about using this as a stackable device and just soldering it to the board, but I think it's going to be too space limiting. It's taking already, maybe 30% of the board. So I'm going to look at how to design my own and go from there. I want to thank everyone for tuning in. Again, hopefully you guys start sending some comments, some features that you want to see in our trolling motor project. We can work on some of those, get some ideas, just understanding what features are important to you. Any questions that you guys have that I can answer would help with the content. I want to thank you guys again, and I'll see you in the next episode. Thanks.